Hello everyone. So in this part, I'm going to discuss about solving ODE using Python notebook. So this is in the part of performance task number 4. So we have a problem here, an inductance of 4. So when we have a problem here, an inductance of 4 Henry and a resistance of 40 ohms are connected in series with an EMF of E volts. If the current is 0 at time t is equals to 0, find the current at the end of 0.01 second if E is equals to 100 volts. So in this problem, given yung we have RL circuit, then inductance of 4 Henry, and resistance of 40 ohms. So we are asked to solve for what is I at t is equals to 0.01 seconds, which is the initial condition is I is 0 at time equals to 0. So the EMF generated is also given, which is 100 volts. So first, let's have to discuss the solution of this problem. So in an RL circuit, we use this equation L di all over dt plus Ri equals to E. So substitute lang tayo ng given, which is ang L is 4. So we have 4 di all over dt plus we have R na 40. 40i equals 2. Ang E natin ay 100. So this equation, we multiply it by 1 over 4. So we will get di over dt, and 40 times 1 over 4, 10 plus 10i. So 100 times 1/4 is equals to 25. So now, i-derive natin siya or i-transpose natin siya into a general form. So magiging di all over dt is equals to 25 minus 10i. So ito na yung magiging equation natin. So after na-derive natin siya into general form, i-integrate natin siya, pero first we have to transpose at pagsamasamahin yung may the same variables. So papagsamahin natin to si di saka all over 25 minus 10i. So integral of this one and integral of dt. So after we get the integral both sides, at this side and this side, we will get negative 1 over 10 ln 25 minus 10i is equals to t plus c. Yun yung makukuha nating integral. So this is now our general solution. So after we get the general solution, mayroon tayong constant c na kailangan nating hanapin, and that is using the initial conditions. So given ang ating initial condition na ang I is equals to 0 at t is equals to 0. So substitute natin ang initial condition. We will get negative 1 over 10 ln 25 minus 10 times I, which is 0. So we will get 0 here equals to t, which is also 0, and that is plus c. So therefore we will get c is equals to negative 1 over 10 ln 25. So after we get the value of c, substitute natin to doon sa ating general solution. Then we will get this one. And ito na yung ating c. Magiging t minus 1 over 10 ln 25. So after na substitute natin ng c, we can now find for the value of I given the t na 0.01 seconds. But first, syempre, simplify muna natin siya to get the equation for our I. So ln 25 minus 10i is equals to negative 1 over 10 plus ln 25 1 all over 10 equals to t. So tinranspose lang natin to sa kabila. And we also bring these coefficients na 1 over 10 into exponent kasi loss of logarithm, pwede yun siya. Pwede natin siyang gawing exponent. So since merong ln and ang kailangan natin is I, nandito siya sa loob ng ln, we can use the exponential. para makancel ang ating ln. Since ang e raised to ln is equals to 1, so this will result to 1, makakancel siya. And it will bring us this result. So makakancel si ln, this one, makakancel this one. And magkakaroon tayo ng the quantity of 25 minus 10i raised to negative 1 over 10 multiplied by 25 raised to 1 over 10, which is equals to e raised to t. And now, ito na siya. So simplify further. Ito na. So since ito ay naka-raise negative 1 over 10, naka-raise siya, that is, gagawin natin siyang denominator lang para maging positive 1 over 10. And since they have the same exponent, pwede natin ilabas sa fraction, and then pwede natin ilipat dito sa kabila, which is magiging e 10 raised to t. Yan. So 25. So simplify, ililipat lang natin ito dun sa kabila, ang denominator. 25 equals to e 10t, 25 minus 10 ay. So distribute natin tong e 10 raised to t. Magiging, ito na. Ang distribute lang. And further simplification, we will get the I, which is 25 multiplied by e 10 raised to t minus 1, and 10e raised to, all over 10e, e raised to 10t. So we have given we have to find I at time t equals 0.01 seconds. So substitute natin lang tong 0.01 seconds dito sa ating na-derive na formula, and we will get the final answer to be the I is now 0.2379 ampere, which is that is on the time t equals to 0.01 seconds. That is after 0.01 seconds, ang makukuha nating current ay 0.2379 ampere. So ngayon, after we discuss the solution, the raw solution of this problem, we now proceed to the solution of this problem in Python. So we'll try to solve this problem in Python. By first, we have to import necessary packages para nakakailanganin natin for solving this problem, like numpy. We have to import numpy, and also from scipy we have to also import the ODE and lastly we have to import the matplotlib. This is for our graph representation para sa ating solution, para makikita natin yung relationship between our time and the current. Kung anong nangyayari sa current as the time increases. So yan yung magpapakita ng ating graph representation. And next, so after na import natin the necessary packages, we now proceed to our function. So our model, we will input here the variable, the independent and dependent variable. So dito, ito na yung equation natin. Note that this is our equation and our dependent variable is I, capital I rather, and our independent variable is t. So So now we will input our equation. So sabi ko nga, ito yung equation natin. Lagay lang natin yan. 25 minus 10 times I. 25 minus 10I. Then we have to return these two. Return. So after we define our function, we have to put our, or we have to let our initial condition to be, let's say, I of 0, I of 0 is equals to 0, which is our current is 0 at time 0. Then our given time intervals. So we have T. So here our time intervals is 0. Given we have to find the current at time is equals to 0.01 na nandun sa problem kanina. That is 0 to 0.01. So now this is the part that we're going to solve for ODE. So our I was to our package ODE model and our initial condition and the time. And then, para makita natin yung result ng I, we have to print the I. Okay, tama. So, at this part naman is our graph representation. I-represent natin dito yung changes in current with respect to time. So, matplatid PLT dot then our label at ang tawag dito? X along horizontal axis. At X axis, ang ating i-label dyan ay our time. Then, ang i-label naman natin along Y axis is our current. Kasi yun yung gusto nating ipakita, yung relationship between time and current. Then, and that's the end of our codes. So, ang kailangan na lang natin ngayon ay i-run. Yan. So, after natin na-run, makikita nyo dito na ang dami niyang sagot because nag-answer yung Python notebook from 0 to 0.1. So, yung mga sagot niya na to is from 0 to 0.1, which is this is the values of current as the time changes from 0 to 0.01. So yung end niya, which is ito, ibig sabihin dito na-reach niya yung time na 0.01, which is ang value ng current na ngayon ay 0.2379, which is ang sagot natin dito, yan, 0.2379, which is same sa nakuha nating sagot for our calculation. So our graph naman dito, as you can see, so we have a linear graph. So makikita natin sa graph na to na yung current have a directly proportional relationship with the time. So as the time increases, malamang dumadagdag din yung ating current. Makikita nyo dyan na at time 0.01, mayroon tayong current na 0.2 na mas mataas pa siya, something here, which is equal to 0.2379 na nakuha nating sagot. So that's it. We already showed the solution in manual calculation and also in using Jupyter or Python notebook. That's all for this presentation.